A real storm is coming. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, February 20th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we see a small gale producing 24-foot seas, all aimed at the Aleutian Islands, just south of the central Aleutians here, not really doing anything. And then the faint beginnings of a possible storm developing off Japan. This is the one that we're going to keep our eyes on and will be the main focus of this evening's discussion. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, that is a dip in the jet, and we don't really have one. But we do have a pretty energetic jet starting to develop, pushing off of Japan, the southern Kuril Islands, right here, with winds at, about 210 knots, pushing due east off the coast there. There is a little bit of a trough right here, a dip in the jet, and what that helps do, it acts like a eddy in a river. It creates a counterclockwise flow aloft. That also works its way down to the ocean surface, and of course, counterclockwise rotating winds in the northern hemisphere are the hallmark of low pressure. Low pressure, of course, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface, generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell, and swell, when it hits your beach, turns into surf. So we have a little trough. We know there's some seas here at like 24 feet or something, not really doing anything, all aimed off to the north. But it is this portion of the jet right here that we're most interested in. So we get into Monday, you see winds building to 210 knots, maybe even 220 knots. You start to see a little bit of something that's kind of like a trough right there off the Kuril Islands. That continues into Tuesday. Now, it's not really a trough because the jet doesn't fall down to the south, but still it's enough to get some rotation going in the upper levels of the atmosphere. Also notice, let's go back here, the split point in the jet right now is like the jet splits somewhere around here, not even probably west of the date line. And as this energetic batch of wind starts pushing across the Pacific, it'll take the split point and push it closer to the U.S. West Coast. During a normal winter, the jet would just roar right on shore. You get a full-on atmospheric river, piles of precipitation, but we really haven't seen any of that this winter. All we've seen is sort of like this backdoor front kind of thing, where the jet splits, goes up into Alaska, falls down the coast, drags some moisture and cold air with it, and you get a light smattering of precipitation, but nothing too intense or too heavy. Anyway, Wednesday, the same pattern continues, and this kind of upper-level low-pressure system just sits over the dateline region. Even as we get into Thursday, the split point then moves to about 145 west, which is just about as far west as it's been this entire winter. We'll go into Friday. Still the same thing. Winds still, even on Friday, 190 knots, pushing the whole way off of Japan. And then the split point gets to, what's that, about, well, 145, something like that. Maybe, I think it gets to, there you go, 140 west on Saturday. That's 1,000 miles off of San Francisco. That's probably about as far as it's going to go. And you see the jet starts losing energy then. We're a week out. Maybe a bit of a trough developing here in the western Gulf on Sunday, but then wind energy starts weakening. The bulk of the jet's energy pushes into the Pacific Northwest. Not sure how much of that's going to make it down into California, but still pretty decent pattern. Late season, it's now mid to late February. I don't know if that's really late season, but for this year it feels like it. So offering some potential for storm development. All right, let's go take a look down at the surface. Here we are, surface level winds, surface level pressure, and as expected, a little tiny gale in that trough right here producing 45-knot winds, all aimed off pretty much to the say the northeast, and not really doing anything to support swell production aimed at the U.S. West Coast or Hawaii. But it is this system here right now developing off of North Japan, Southern Kuril Islands, right in this area. 40-knot winds, building as we get into Monday morning, 50 to 55 knots, but mainly 45 knots over a pretty broad area. I mean, this is a legitimate, real decent-sized gale, the first one we've seen all winter. And even as we get into Monday night, still 45, 50-knot winds, and even 35-knot winds. That's gale force winds right here over a large area. I mean, pushing from Japan to 2/3 of the way to the date line. That's pretty impressive. Continuing as we get into Tuesday, even Tuesday night, still 40 to 45-knot winds, slowly pushing off to the east. Then by Wednesday, the gale starts fading, but you see 30-knot winds from the Kuril Islands the whole way to the date line and beyond into almost the western Gulf. That is a broad fetch area. Good for getting traction on the ocean surface, certainly generating some seas. Then we get into Wednesday night. The gale starts winding down. And as we get into Friday, it's all but gone. Then we kind of go with sort of a slack pattern for a bit. But then theoretically on Sunday, another little gale develops in the northwestern Gulf. I mean, that's almost a week out. Don't know if that's really believable. And then maybe another system off here in the western Pacific. But again, a week out, so we're not holding our breath on that. But the one forecast, in fact, we'll just go right on around the loop. This one here, this seems like pretty much of a sure thing. It's been on the charts for a week or more now, and it seems to be developing pretty much like it was forecast even 5 days ago. So that's a good sign. All right, let's go take a look at the effect of those winds on the ocean surface. Here we are, significant wave heights for the North Pacific Ocean as of 18Z Sunday. Not a whole lot going on in the West Pacific just yet. But as we get into Monday morning, 12Z, that's about 4 a.m. California time, seas starting to build 35 feet, right there, 35 feet. That's the highest seas over this entire domain at 39.75 north, 152.0 east. I know you deeply care about those exact coordinates, but I do. Anyway, seas building to 42 feet as we get into Monday night, 43 feet later Monday night, and then Tuesday morning in about the 41-foot range, something like that. And continuing just plodding off to the east, approaching the date line on Tuesday night with 39-foot seas. Highest seas right about, let's see, it's the plus sign right there. And there it is right there. The highest winds just a little bit north of that at 47.1 knots right there. So looking pretty good. That continues as we get into Wednesday, but the gale fades. I mean, seas start fading from 35 feet. And then by the time this thing reaches the date line, which is still a long ways away for California, but not so bad for Hawaii, actually pretty well positioned for Hawaii, we have 29-foot seas forecast, and then fading from there, all but gone. And then we get into, here we go, on Sunday, the next little gale starts winding up with 28, 29-foot seas. Maybe a little pulse of energy for California, if that even materializes. Then maybe another system over in the West Pacific. But again, way too early to know for sure. All right, max swell period. This is in no way indicative of size. These are very tiny little swells here pushing across. The point is we're really looking at this system here off of the West Pacific. You can sort of eyeball it and see. So what periods are that? That's 1, 2, 3 in the purple, 1, 2, 3. So 20-second period forecast, almost 21-second. At some point pushing into the Hawaiian Islands right about there on Thursday evening. And then into the U.S. West Coast. Whoops, go back on maybe Saturday, something like that. Saturday afternoon, and then fading out. Now again, no indication of size here. But then this chart is an attempt to depict surf size, not in the core of the storm, but as the swell sort of gets defined and radiates out away from the storm. So we'll play this game. And you see there's these blank areas here. That's actual fetch area where there is not quote-unquote swell. It's just a very agitated, raw wind swell sea state. So you can see the storms here, but there's nothing in the middle yet because it's so agitated. There's, it's the integration of swell and period, swell height and period, that makes rideable surf. I mean, yeah, raw wind makes surf, sort of, but this is a little bit more. You see, as things settle down in the storm, the projected wave heights start building. Still, when you're right in the fetch, you don't want to use that. It's more once the swell starts radiating away from the fetch area. And here's Hawaii. We get into Thursday, and you can see heights here pushing, well, right at about the purple, which would be 20 foot. That's 20-foot faces, but in Hawaii, that's probably more like 20-foot Hawaiian. And then into the U.S. West Coast, probably in the, what's that, the 10-foot range, something like that, maybe a little bit more, pushing 15 feet, something like that. Again, all a projection. And then there's that new system that starts developing behind that, and another one behind that. So it's kind of a hard chart to read, but it does a reasonably good job of giving you estimations on when swells will arrive, and gives you a visual, right? Rather than, there's other ways to get to this through looking at, bunches of tables of data or calculating it yourself. But if you just want a quick look, these are available on Stormsurf, and you can find them there in the wave model section of the site. Now, in addition to all that, there's actually some weather forecast, but we're kind of looking right now at winds, right? And for California, the big thing is it looks like a wind event is setting up. And here we go as we get into Monday. 30-knot winds along most of North and Central California, and even working their way down into Southern California. I think it's on Tuesday. There you go. 25-knot winds all along the North Central California coast. Just a mess. Relatively light trades for Hawaii, or like northeast kind of trades. As we get in Tuesday, pretty much all a mess. Wednesday for California, still a mess, but starting to clean up. Relatively more normal trades finally developing for the Hawaiian Islands at 15 knots on Wednesday. Thursday, winds lighten up for California. Trades start building a little bit for the Hawaiian Islands at 15 knots. But the core of the high pressure here is set to push into the California coast. And right over the core of the high, there's really not a whole lot of winds. And if you're out far enough away from the edge of the high, not so much winds either. So we get into Friday. Trades for the Hawaiian Islands, a pretty light wind regime for California. Saturday, pretty much the same deal. And Sunday, more of the same. And then you can see spurious low pressures here in the northern Gulf of Alaska, but no obvious weather producers for California. Go out there. There's your last frame. Precipitation. Yes, relative to California, there is actually, believe it or not, a little bit of precip forecast. Backdoor front, typical thing we've been doing this year. Monday, you can see the precip starting to build. We know the jet's sinking down, sort of doing this backdoor front thing, dragging light precip snow over Oregon on Monday, down into the Sierra with snow, and North California, and along the coast as we get into Monday and Tuesday. Even some precip for Southern California, maybe Tuesday and Wednesday. A little bit more snow for the Sierra, and then clearing high pressure sets up, and then it's pretty much dry after that, with the focus being, we'll say, British Columbia down into Washington, maybe Oregon, something like that, but nothing really for California a week out from now. Here's the snow model. We look at that. You can see focus right now, Oregon, Washington, a little bit here in the Sierra starting Monday morning, Tahoe region for the most part, till we get into Monday night. A little bit broader area of snow working its way down the Sierra on Tuesday into Southern California, and then by Wednesday things start clearing out. We'll just go out. This model goes out 10 days. More precip for British Columbia down into Washington on, what is that, Sunday, Monday, and then yet more on Monday, almost into Tuesday, but nothing for California. And yet another one as we get into Wednesday, but California locked under high pressure and dry. Calculated snowfall amounts for Squaw Valley, Olympic Valley, about 10 inches, all pretty much on Monday and Tuesday, and then nothing after that. Snow levels, you see at about, or the freezing level at about 8,500 feet today, steadily falling, going down to maybe 1,500 feet on the 22nd into the 23rd, and then after that, that's our big event, and temperatures start creeping up. We're back up into about the 11,000 foot range after that. Sugar Bowl doing about the same thing, let's say 1 foot of snow. Kirkwood at about 6 or 7 inches. And Mammoth, because they're so much further south, and this is one of those backdoor fronts falling north to south, all the moisture wrung out by the time it gets there, even though Mammoth is much higher. What, an inch or two, something like that. Every little bit counts, though, and we'll take it. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and El Nino La Nina, the El Nino Southern Oscillation. So as usual, we'll start by talking about the MJO, the Madden Julian Oscillation, this periodic weather oscillation. It has 2 phases, an active phase and an inactive phase. It rotates around the planet on the equator, moving from west to east. The active phase on one side of the planet, the inactive phase on the other, they rotated around. When the active phase is over the Pacific, the inactive phase is over somewhere in the far Atlantic, Indian Ocean sort of thing. The active phase is the one that we're interested in. It is effectively a low pressure system. It imparts energy to the jet stream, which feeds the jet. And based on what we've seen on the jet stream right now, one would assume that the active phase is getting ready to push its way into the West Pacific. It also, when the jet is energized with energy, it then in turn helps produce storms. It also, the active phase, because it's a low pressure system, it actually suppresses trade winds where it is over the Pacific. And that's good. That, or if not, out and out reverses trade winds. That can in turn, if you get westerly anomalies instead of easterly winds over the equator, that can take warm water that's normally in the West Pacific and help push it off to the east. So today, this is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they also have wind sensors on there. These are not like real-time 1-hour winds or 5-day average winds, but that's good enough. We just look at the size of the arrow and the direction, and you get a sense of, well, that's pretty strong easterly trades over the East Pacific. This is the East Pacific here, West Pacific here. That's the equator right there. Date line right there. That is New Guinea. It's not somebody's finger pointing down. All right, so we have easterly winds over the East Pacific, pretty strong easterly winds over the Central Pacific, and pretty strong easterly winds over the Kelvin Wave generation area. This part of the West Pacific from 170 west, 5 degrees north and south of the equator, so it's not really a very big area. But if you can get these arrows to start pointing the other direction, or at least go calm, warm water that's here will start pushing off to east. That's known as a Kelvin wave. If you get successive active phases of the MJO that generate successive Kelvin waves, then that can help kick off El Nino. So we're very focused on the active phase of the MJO because it not only, one, helps produce swell and storms by feeding energy to the jet, but it also, two, can set us up for warmer ocean temperatures on the equator, El Nino, which I think we all know is great for storm production and for bringing precipitation into California. All right, but it's not the actual wind speeds, it's the anomalies. Differences from normal for this time of year. Yeah, the winds are pretty strong here out of the east right now. Looking at this, you see the arrows. The anomalies are also out of these, so these are actually stronger than normal for this time of the year. Enhanced trades here. Same deal over the Central Pacific, and same deal over the Kelvin Wave generation area. So no clear indication at this moment in time of the active phase of the MJO over the Pacific based on trade winds. But we know based on what's going on, or at least we suspect from what's going on with the jet stream, we saw that previously, that it's set to rage, and that typically is a sign of the active phase of the MJO. The forecast for the next week, MJO forecast. Okay, this is 850 millibar zonal wind anomalies. Fancy words for are the winds blowing stronger out of the east or stronger out of the west. We want west anomalies. We don't want east anomalies. But what do we have here? Well, let's see. Here is past performance. Here's the forecast down here. We see a whole lot of purple. Let's get ourselves oriented. This is the whole planet on one chart. The date line runs right up the middle. We don't care what's going on over in Europe. We don't care what's going on in the Atlantic. It's the Pacific that we really are interested in, only on the equator. So anyway, from about 135 east, so right there, that is the far, that's like New Guinea. That's even west of there, to about 170 west. Those are the bounds of the Kelvin Wave generation area. That's where all the magic happens in the Pacific. And we see the blues, purples, those are easterly anomalies. So we've had this persistent easterly anomaly pattern. And then you see easterly anomalies building very strong, intensely strong over the next week, right in the smack in the middle of the Kelvin Wave generation area. How can that be happening when we think that the active phase of the MJO is starting to set up? And I think it's just a matter of time. This really is probably the last pulse of this long-running inactive phase of the MJO that's been in control. All right, so another dimension of the MJO. Remember we talked about the MJO is like a low-pressure system. Well, low-pressure systems generate clouds. High-pressure systems, which the inactive phase of the MJO is high pressure, that clears out clouds, clear air. So this is outgoing long-wave radiation prediction, cloud cover prediction. Let's get ourselves oriented. South America here, that's Chile, Peru. Central America, Hawaii. New Guinea there, the dateline 180 west right there, the equator right there. Kelvin Wave generation area right here, the West Pacific, 170 west to 135 east, 5 degrees north and south of the equator. Reds here are more sunlight reflectivity off the ocean surface, high pressure, the inactive phase of the MJO. This per the statistic model. 5 days from now, the inactive phase moving east, fading. 10 days from now, moving east, fading more, and you see the active phase, more cloud cover over the maritime continent, starting to push into the West Pacific. And then 15 days from now, 2 weeks from now, the active phase of the MJO moving into the West Pacific. That's per the statistic model. Now, the dynamic model, not quite as aggressive as suggesting the inactive phase building a little bit stronger and lasting longer. Here's the last chart of the statistic model. On the date line, you see the active phase in control. And the dynamic model suggests the active phase still just starting to get its foot in the door in the West Pacific with the inactive phase holding on. So a little bit of discrepancy between the two, but only a 5-day difference. So that's really not too much. Phase diagrams here. Statistic model, dynamic model, just drill in a little bit deeper. So the heavy dot is where the active phase is. Okay, and the MJO, inactive or active, moves from west to east, from the Indian Ocean over the maritime continent to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. So here's where the active phase is. The further the dot is away from the circle, the stronger it is. So we'll say a modest active phase, the MJO over the East Indian Ocean. And over the next 2 weeks, 3 different projections have it put somewhere, just starting to enter the West Pacific at weak strength. The dynamic model, pretty much on the same course, maybe not quite as aggressive as at least this one right here, holding back a little bit and not quite as strong, but pretty much in sync. The upper level model indicating areas favorable for precipitation. The greens are favorable, the reds not favorable. This runs about a week ahead. This is up at jet stream level. So let's get ourselves oriented. South America there, Central America, New Guinea there. 0 is the equator. Dateline roughly right there. So this looks like dry air, the inactive phase of the MJO, making its way and pushing itself out of the Pacific about the 2nd of March as the active phase builds in the West Pacific starting about the 25th of February. But remember, this is about a week ahead. What's going on in the upper levels, what happens out in the surface, the surface drags behind. So we'll say the early part of March. And then the active phase, pretty solid, making its way across the Pacific into about March 22nd, so that'd be about the end of March. And then the inactive phase comes in for April, does its trip across the Pacific through the 1st of April, so a little bit longer than that down at the surface. All right, the next CFS forecast going out 1 month. Again, the whole planet on one chart. Dateline runs right up the middle. Kelvin wave generation area right here in this area. The blues, and this is east-west component of the wind. The blues, easterly anomalies. The dotted contour, the inactive phase of the MJO. The solid contour, the active phase of the MJO. So you see the inactive phase of the MJO pretty solid over the Kelvin wave generation area today, holding for about the next week to week and a half, almost 2 weeks, something like that. And then the inactive phase fades out. The active phase actually is present with solid contours, pushing into the West Pacific, making it to about the halfway point by about March 5th and continuing on across the Pacific. Now, this model suggests, you see this, these oranges and reds, the westerly anomalies only making it to the dateline and stalling, with the easterly anomalies holding past that into later in March. But another model suggests that's maybe not true. And this is the CFS model going out 3 months, okay? We don't believe a model going out a week, so certainly not 3 months, but it actually does, this model does a reasonably good job. All right, so this is the same deal. The blues are easterly anomalies, the yellows and oranges are westerly anomalies, but past performance, what's already happened is down here. The forecast is up here. Kelvin wave generation area starts about 135 east, so this area right here to about just a little bit west of the dateline. What's really striking is you see this big patch of easterly anomalies from now into about March 8th, and then they completely disappear, and all we're left with is this weak, steady westerly wind pattern after that. That's actually a good sign, because we've just been marred the entire winter and the winter before that with easterly anomalies, and the sense is that pattern, easterly anomalies in the Central Pacific, that pattern is starting to fade. We think that is attributed to the fading or the dissipation of La Nina. Let's overlay the MJO. All right, so the dotted contour, inactive phase of the MJO, here's where we are today. It's supposed to hold over the Kelvin wave generation area. There we go, right in that area. But fading out as we get and out of the Kelvin wave generation area by March 8th, the active phase of the MJO sets up pretty strong one here. 1, 2, 3, 4, 5 isobars. That, we'll see if that really happens. This model tends to overhype some of this, but you see westerly anomalies, not particularly strong, but steady westerly anomalies filling the Kelvin wave generation area by somewhere in the early part of March. And then even after the active phase fades in, when's that? Mid-April? Inactive phase comes in, but westerly anomalies supposed to linger beyond that. Why is that? Well, let's take a look at the low-pass filter here. So this is the El Nino La Nina indicator. The dotted contour, high-pressure bias, La Nina, sitting as it has all winter smack over the dateline. But you see, it's supposed to start slowly pushing east and pretty much out of the Kelvin wave generation area and east of the dateline by the early part of May. And the low pressure bias, which has been over the Indian Ocean for past 2 years, is supposed to start making some decent headway into the Kelvin wave generation area. In fact, it's already on the edge of it right now and continuing to push off to the east. That was, and building with a second contour as we get into later April and May, pretty much signaling a pattern change for the rest of this year and beyond that, hopefully for the next several years. Kind of hard to tell, but this at least gives us some hope. If we can just get through the next month or two, things probably should get turned to a much more positive outlook. All right, let's go take a look down in the ocean. What's going on, not at the ocean's surface, but subsurface temperatures. This is the West Pacific here. This is the East Pacific here. This is data from the TAO buoy array again. These are the anchor lines on the buoys strung across the equatorial Pacific. The X's are sensors on those anchor lines. They are temperature sensors. You take that data from all these buoys, you apply a model to it to fill in the gaps, because you can see some of the, there probably should be a buoy right there. There maybe should be something here. There should be something here, but it's not there. But you you take the data, average it out, guess what what's in between. You get a profile of the subsurface temperatures. Warm temperatures, the 29-degree isotherm. It was pushing off to the east, but it's backing off now about 170 east. I think it was over at 175. The 28-degree isotherm was over about 175 west. It's backtracking now too, so you get the sense that warm waters are tracting a little bit. But the 24-degree isotherm, which all winter has been somewhere between 140 and 120, pushing the whole way into Ecuador right now, and suggesting that warm water is on the move to the east. But it's not the actual temperatures here. Again, it is the anomalies, differences from normal for this time of year. And if you recall, over the East Pacific, all winter long, there's been nothing but cold water, below normal temperatures for this time of year. Now we have warm water flowing from the West Pacific the whole way into the East Pacific and about ready to start impacting Ecuador somewhere in the next couple of weeks. This is a classic Kelvin Wave scenario. We had a active phase of the MJO a couple of months ago. It produced westerly anomalies. It tapped this warm water here, started pushing it to the east, but not at the surface, sort of under the surface, and creates this river of warm water streaming the whole way across the Pacific. If we can get another active phase of the MJO over here with westerly anomalies, it'll tap this warm water, start pushing it off to the east as well as the high pressure bias moving out and starting to move east, and the low pressure bias taking over in this area. That might continue to feed that warm water flow. We'll see, but at least for the moment, things are looking much better. Another modeled view shows the warm anomalies pushing their way all the way across the Pacific to 100 west. So that's, what, south of the Galapagos? Just south of the Galapagos would be right there. Just down, not even, maybe 35 meters. So what's that, 100 feet below the ocean surface? The last little pocket of La Nina's cool waters are right here, getting squeezed to the surface. You can see them sort of getting caught by the trades, drifting this way. But it is this flow that is pushing off to the east that we think is going to terminate La Nina for good. All right, sea heights. Let's see, sea level anomaly. This is not temperatures. This is the height of the ocean. You strip out all the waves, strip out the wind waves, strip out even the tides, and is the sphere of the ocean higher or lower than normal? If it's higher than normal, the thought is if you have warm water at depth, it expands, and that sort of pushes up on the ocean surface and makes a bump, a bulge. If you have cold water at depth, it contracts, creates a divot on the ocean surface, and you have negative anomalies. So right now we have warm water in the West Pacific. Oh, yes, let's see. Equator, dateline. This is kind of a hard read chart. South America, this would be Chile, Ecuador, there's the Galapagos, Central America, Hawaii right there, New Guinea there. So warm water here, but what you also see is if you look real carefully, there's this stream here, or this finger pushing this way, and this is that warm water at depth. It's not super warm, but it's warm enough, and you see some evidence of it even at the surface in places, trying to work its way towards Ecuador. The leading edge right here is about 105 west. Okay, the last little bits of the negative anomalies, -5 centimeter anomalies, and that's Ecuador right there, that's Galapagos there, right near the Galapagos, and that's pretty consistent with what we saw in the previous chart. Upper ocean heat anomalies. So this paints the picture really well. West Pacific here, East Pacific here. Time going back a year, February of 2021 to February 2022. The reds, of course, are warmer temperatures. This is back last March. We had a active phase of the MJO that created a Kelvin wave, and see the warm water pushing the whole way across the Pacific. 1, 2, 3 of them through about July, and then everything collapsed. And then we had the exact opposite, cold water Kelvin waves. 1, 2, 3 in August, September, November, December, driven by the inactive phase of the MJO. And now here we go, active phase of the MJO back in the November, December time frame. Here's our leading edge of our Kelvin wave to about, making it to about 105 west and expected to push on into the coast. And it almost looks like maybe the start of another Kelvin wave trying to push this way. But I think we really need another active phase of the MJO to tap this warm water to try to create something. Now, a bit of the concern here is look at the extent of the warm water here today. Look at the extent of the warm water here a year ago. And also notice that even last summer, we got this cool pool buildup as we got into summer. The question is, will that happen again this coming summer? And the thought is, if the low pressure bias makes it over into this area around here, that will prevent this sort of scenario from happening. This happened last year because we had a high pressure bias locked right over the date line, the typical La Nina sort of indicator. We think that's all going to fade, so we won't end up where we were last year. And maybe as we get into summer, that could be a harbinger for at least a little bit better of a swell pattern. All right, we've talked subsurface stuff. We've talked the MJO and high pressure biases and low pressure biases. But what's going on at the surface of the ocean? That's really what matters, right? It's the interaction of the surface of the ocean with the air directly above it. And the two of them interplaying with each other is what creates our weather or dictates our weather patterns. Now, the good news is, okay, so this is kind of a little bit hard to read, but South America, Central America up into here, Baja, Hawaii right there, the equator running right down the middle. Blues, colder than normal temperatures, but we had this raging cold water all year in this area. And then even 2 weeks ago when we did our last video, there was still pockets of significantly colder water right in here. That's all gone. You're getting this, it's still cool, but warming, and a little bit of warming setting up in pockets here along the equator. Now, we're not saying that this is El Nino or anything like that, but we're just trying to suss out the demise of La Nina. Now, we do have this cold little pool right along Peru. That is pretty normal. I mean, trades rage pretty good here. If the inactive phase of the MJO sets up particularly strong, it could have some effect here temporarily. But we know at depth there really isn't any more cold water, so kind of hard to see this building anything. If anything, this pool of cool water should be collapsing. Sea surface temperature trend for the past 7 days, pretty much as expected. Warming. Peru, Chile, Peru, Ecuador right there. What really matters is right here on the equator. And you see warming the whole way from about the Galapagos, the whole way out to 140 west, and then off of Peru and Chile, warming. These are all good signs suggesting La Nina is fading. And then the backed off view, yes, a broad area still of cool water. I mean, it's going to take a long time for this to all dissipate. But the intensity, the really cold water that was all right here on the equator is all but gone now. This is more like just a hangover from La Nina, if anything, unless something happens in the next couple of weeks. We suspect this water will continue to slowly dissipate. I mean, it's going to take months for it to fully be gone, but the slow demise of this cool pool is what we're keeping our eyes peeled for. The Nino 1.2 sea surface temperature index, updated daily. Today, 1.577 degrees below normal, about 1.5 degrees. Now, this is a pretty noisy area, but still, it's cold. I mean, it's been cold. We had a little spike there in January, but now we're retreating back. Probably due to those localized winds off of Peru causing upwelling there. But it's the Nino 3.4 index. That's the official El Nino monitoring region. The area on the equator from a point south of California out to about the date line. Sea surface temperatures today at a little under 0.5 degree, 0.684 degrees right there. The threshold in this region for La Nina is 0.5 degree below normal. So we're still in La Nina territory, but just barely. We're off by 12 hundredths of a degree or something like 18 hundredths of a degree, sorry. So almost 0.2 of a degree. But the trend, well, we've bottomed out and we think we're upwards and we think we're going to go upwards from there, but there is some debate about all that. We'll get into that in a second. we talked about the interaction of the ocean's surface and the air above it. There is one more index we look at, the Southern Oscillation Index, difference in pressure between Tahiti, which is basically sort of in the central Pacific, and Darwin, which is roughly in the Indian Ocean. When pressure is lower over Tahiti, which would be El Nino, the index goes negative. When pressure is higher over Tahiti and lower over Darwin, that is La Nina. All right, and the MJO can create differences as well. The active phase of the MJO can temporarily drop pressure over Tahiti relative to Darwin, making it look like driving the index negative. So today our value is 5.00, which is still suggesting weak high pressure over Tahiti. And looking back, we see we had a couple of negative readings there, but we've had a bunch of really positive readings for a long time. A little bit of weakness in this area here, but still pretty much positive. The 30-day average 30 days, these numbers together to get sort of a cleaner picture of what's going on. The value still positive, 10.07. We got up to, what, 10.60 a couple of days ago, and that was probably the highest we'd been all this year. Last year, this got up to plus 19. So we're doing better than last year, and certainly looking at the water temperatures, sea surface, and subsurface temperatures in the Pacific, you can see why the pressure difference would not be as strong last year. The 90-day average is your El Nino La Nina indicator. Today, plus 7.95. We got a high of probably right around there, what, 9.2537. Nope, 9, still looking here. It's 9.63. Last year, this was up at about plus 15. So still indicative of a La Nina, but not nearly as strong as last year. In fact, let's go look at a graph of this data. Here we go. All right, so here's our current value, somewhere around 10 roughly. This chart is not exactly in sync with the data there. Two different indexes. They both have a slightly different methodology, but the net result's the same. All right, so back in January 2020, we were in a weak El Nino, negative values. And then in July, you see, so these upward spikes are the inactive phase of the MJO. It just roared, pushed us into La Nina in 2021. The 30-day average went to, this one says about 21. We got a little bit of a break in last spring, and then it came back again. And then here we are today at about 10 or so. These are the active phases of the MJO. We want to see this drop way down here. We don't know if that's going to happen immediately, but at some point we're hoping it will. So that brings us to the debate. What is going to happen long term here? The CFS model forecast for sea surface temperatures in the official Nino 3.4 region as of today has temperatures, somewhere around 3/4 degree below normal, and suggests that at least the raw model suggests temperatures falling back down to about 1.25 degrees below normal, which, looking at everything we're seeing ago, I don't see how that could happen. I guess it's possible. And then as we get in July, temperatures is hovering around -1 degree, which is still clearly in the La Nina category and likely going into the fall. The threshold is 0.5 degree. Now this is sort of the raw one. The PDF corrected, which is maybe a little bit more accurate, says temperatures falling down to about 1 degree in May or something like that, and then pushing back up to about 0.8 of a degree, but still hanging in the 1 degree below normal, clearly La Nina territory as we get late into fall of this coming year. We're really scratching our head on that. And then let's add just more fuel to the fire. The RRI CPC consensus. This is taking all these different models here, laying them out on one chart, and there's strengths and weaknesses. Some of these are dynamic models, some of them are statistic models, but you see that the average of all these models right here toggles, well, there's 0 right there. The CPC consensus, whoops, see if we can get it to pop there. There we go. Right at about 0 and hanging, and the dynamic average right at about 0. As we get into, let's see, that's April, May, June, July, August, September. So about neutral as we get into midsummer. We can look at the table down here. And we're not going to get into looking at every one of these models, but the CFS, here's the CFS with all its negative readings right here. And you kind of look, well, yeah, the GMAO model also sort of suggests the same thing. You look at a bunch of these other models, and, you know, the question is, well, whose model is more accurate, and how do you weigh this out? Well, hard to say. Here's the average of all the models. Right now, we're at -3/4 of a degree. They say we'll be at about neutral in, somewhere in July, August sort of thing. And then as we get into the fall, holding at about neutral. So the million-dollar debate is, which model is right? Regardless of all that, the good news is we have a gale right now developing off of Japan, going to produce some decent-sized seas. And it's not so much the sea heights, but it's the magnitude, the total aerial coverage of those seas, and the fetch, which is quite solid. The net result is we think a solid, longer period swell is going to result for Hawaii and the U.S. West Coast as we get into the later part of this week, and that should produce some surf. But after that, things might slow down a bit. Maybe one little gale for the northern Gulf. We'll see. Looking longer term, the jet stream, solid indeed. We think that is being driven already by the active phase of the MJO over the maritime continent, feeding it. As the active phase is forecast to push into the West Pacific about 2 weeks from now, we think the jet stream is going to wake up some more. The storm track will continue to be reasonably solid, and we should have a decent run of late season swell. That's certainly a guess. The models don't, really run out that far so you can know, but our best guess is we're probably good here for a couple of weeks. But after that, then it's all over. Spring sets in earnest, and we're kind of done. In terms of rainfall, well, a little bit of rain, a little bit of snow for California. Mainly snow, not so much rain for the urban areas. But a bit, maybe a foot in the Tahoe area, if you're lucky, 10 inches, something like that. And we've looked out at some other longer-term models and suggest maybe there's some more coming. We're at 75% of average rainfall and snowfall as of right now for the entire season. It would be nice to get us to 100%. We have no illusions that we're going to get above 100%. I think we'll be very lucky to make it to the 100% mark. So take whatever you can get, make the most of it. Swell-wise, pretty much the same thing. Long-term, the million-dollar debate is, well, is the CFS model right, and our sea surface temperatures going to fall back down to a degree below normal as we get into the summer? Or are all the other models right and say we're just going to return to sort of a neutral pattern? I suspect the neutral pattern seems more realistic, but nature does what it wants to. The atmosphere does what it wants to. It's going to be kind of hard to tell. I think as we get out of the spring unpredictability barrier in the models, that would be in about the May to June timeframe, we'll have a lot better handle on what's going to happen for this coming fall. But for now, it looks like the high pressure bias is moving out of the Kelvin wave generation area. Low pressure bias is moving in. To me, that signals the demise of La Nina. That would just set us up for a neutral pattern beyond that. And neutral is better than La Nina any day of the week. We'll take it. All right, so that's it for this week. If you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe right down, over there. There's a button that says subscribe. Click on that, actually it's the Stormsurf icon. Hit that, and then you have the opportunity to subscribe to get automatic notifications when we post the video. That is every Sunday, roughly around this time, except when we don't do it. And then, if not, go to stormsurf.com. All the data you saw tonight is present there. You can build your own forecast, follow along day by day, test your knowledge at the end of the week with your own personal forecast, compare it to what we publish here, and if you disagree or you have questions or you don't understand, give us a comment. We'd be happy to answer. This is all about trying to educate everybody so that we're all a little bit smarter and a little bit more dialed into what the environment is doing and how we interact with it and how we can use that to our advantage to get more waves, get more snow, hopefully get some rain, and live happier and healthier lives. All right, so that's it for this week. We'll see you again next week, same time, same channel. Thanks for watching.